And if you have any ideas, you can put it in chat. Nobody has any ideas. I guess I can show you some test cases. Let's see. Soham says maybe some of black intersecting areas intersecting areas of the two blacks. Yes, that's part of the problem. And you can see here for our first test case, we're gonna have count the contained corners. Also a good idea. But for our first test case, we're gonna have two here. Then we're gonna have we're gonna have a 4 and the other coordinates for the white sheet. And then we have for the first black sheet we have 1 right here as a blue dot and 3 5 for the top right corner and 3 5 for the top right corner, and then you have a black sheet. And now you have 3 1 for the second black sheet bottom left corner, and then 5 5 3 1 for the bottom left corner and 5 5 for the top right corner. So we have another black sheet, and this covers this covers a whole white sheet, so the output is no. And for the second test case, you have 3 3 as the first. You have 3 3 as the bottom left corner for the white sheet, 7 5 as the top right corner for the white sheet, and then the other two corners, and now we have the white sheet, and then we have 0 0 for the first black sheet, and then 4 6 for the top right corner of the second black sheet for the first black sheet, and we can get the other two corners, and we have this black sheet. Then we have 0 0 for the second black sheet, and then 7 4 for the top right corner of the second black sheet, and then yeah, we can still see the white sheet, so the output is yes. Does everybody understand the problem? So can move on to like the logic. And does anybody have like any ideas for the logic of this problem? Like you can raise your hand if you want to. Sorry if I said that wrong. Do you have an idea?
You could try and find the area of the intersections of the black squares and the white squares, rectangles,
Yeah.
and subtract the intersections of the two black rectangles. And if
Yeah.
that's more than 0, then
You could see the white sheet. Yeah, that's exactly the idea for this problem. So you first find the area of intersection between the black and the white rectangles, and then you find the area of intersection between the two black rectangles, because that could be an edge case. And then you add up the intersection between black and white rectangles, then subtract the area of intersection between the two black rectangles if this is more than the area of the white triangle. So basically, if you add this up and subtract it, and this is more than the area of the white rectangle, then you can't see the white rectangle because the area of intersection is just going to cover all of it. So here we have a visual, and this is the two black sheets, and this is the area of intersection. This is the area of intersection between like the two black sheets, and then we have the area of intersection between the first black sheet and the white sheet, the second black sheet. So we want to add these two green areas up, and then since these two green areas have an intersection, we want to subtract that. And if that is bigger than the white sheet, then we can't see the white sheet. But in this case, after you subtract this area, it's not bigger than the white sheet. And then yeah, you basically calculate the intersection with the black and white sheet, and then the other black and white sheet, and then you calculate the intersection between the black and black sheet, and you add. Let me go back to the previous slide. and then you add up the intersection between the black and white rectangles, then subtract the intersection between the two black rectangles, because the two black rectangles are gonna be double counted, like the intersection between them.
All right, thank you.
And then we need to have an implementation. So Soham said that he tried to code the exact logic of what we just did, but for some reason it didn't pass. So maybe the implementation had a problem. So this is going to be the implementation. So first we have to check. We have to make a function to check if two rectangles intersect. And the way to do this is you have the only times when two rectangles don't intersect is when the larger of the for one rectangle, the larger x is smaller than the, okay, so this is I should switch the color. So for this one, this is a larger x of one rectangle. So this is x2, and then this is x1 for another rectangle, and then this is larger than the largest one of this triangle. So there's a gap here. And then for this case, you have a smaller y1 here, and this is y2 of another rectangle, and these are the only two cases where like the rectangles don't intersect. And this is the implementation to check that. Like if x2 of one rectangle is smaller than the x1 of another rectangle, or the y1 of one rectangle is bigger than the y2 of the other rectangle, then they don't intersect. Does everybody understand this? Like, does everybody understand the logic for like, yeah. And then this is the Java code for if they intersect, so it's pretty much the same thing as the C++ code, but in Java. And now we have to find the area of intersection. So to find the area of intersection, we have to find the larger x of the larger x, so x2 of one rectangle that is larger than the x1 of another rectangle if they do intersect. If they don't intersect, you will be just calculating plane error, I guess. So if they do intersect, you want the x2 minus x1 of the other rectangles, and then you get the widths, and then you have and then you want to do the same thing for the length. So you want a y2, so this is a y2 for one rectangle is larger than the y1 of the other rectangle, and that's gonna be the length. And then after after you check if they intersect and find the area of intersection, you start like going to the main logic, which is this is a Java code for the intersection. So for the Java code, you just use a normal array. And then, so then you want to do logic implementation. And this is after you did the functions for checking if they intersect in the area of intersection. And then, so this is the input. We want to CIN all the white sheet, the black sheet, and the black sheet number 2. And then we want to create the rectangles in our vectors. So these are all the rectangles that are these are all the rectangles. And then for this, we want to find the intersection between the black squares. If you see, if intersect black square 1, black square 2, it just calculates the area of intersection, which is this right here. And then after you get the intersection area of the black rectangle, if the black rectangles don't intersect, it's just 0. And then after you get the intersection of the black rectangles, you can get the intersection of the black and white rectangles. So black 1, black 2, and this is a white sheet. And then you can have, and then these are the intersections. After that, after we calculate the intersection areas of the black and white rectangles and the intersection area between the black rectangles, we can take the intersection area of the black and white rectangles and then like subtract the intersection of black rectangles, because this is gonna be that area right here, right there is gonna be double counted.